In June 2017, 8 researchers at Google published a 15-page paper with a strangely confident title, "Attention is all you need." No press conference, no product launch, just a PDF. That PDF is now one of the most cited papers in the history of computer science, and almost every AI system you've touched since, every chatbot, every code assistant, every image generator, is a descendant of the idea inside it. This is the story of what happened next. To understand why this paper mattered, you have to understand how broken things were before it. In 2017, the best language, AI read text the way you'd read through a keyhole, one word at a time, in order. These systems, called recurrent neural networks, had 2 fatal flaws. First, they forgot. By the time they reached the end of a long paragraph, the beginning had faded away. And second, because each word depended on the one before it, you couldn't parallelize the work. Thousands of powerful GPUs sat waiting in line behind a single file process. Progress was crawling. Something had to give. The Google team's proposal was almost reckless in its simplicity. Throw out recurrence entirely. Instead of reading word by word, let every word look at every other word all at once. This mechanism, called self-attention, lets the model learn which words matter to which. In the sentence, the animal didn't cross the street because it was too tired. Attention is what tells the model that it means the animal, not the street. They called the architecture the transformer, and because everything happens in parallel, it was a perfect match for GPUs. Suddenly, the speed limit on AI wasn't the algorithm anymore. It was just compute. Here's a detail that tells you how big this became. Nearly all 8 authors eventually left Google, most of them to found their own AI companies. What followed was one of the strangest discoveries in modern science. Transformers got better in a predictable way as you made them bigger. In 2018, OpenAI's GPT-1 had about 117 million parameters. GPT-2, a year later, over a billion, and it wrote text coherent enough that OpenAI initially hesitated to release it in full. Then in 2020, GPT-3 arrived with 175 billion parameters, and something surprising emerged. It could perform tasks it was never explicitly trained for, just from examples in the prompt. Researchers called these scaling laws. More data, more parameters, more compute, better model, almost like a law of physics. And it wasn't just language. In 2020, DeepMind's AlphaFold used attention-based architecture to crack protein structure prediction, a 50-year-old grand challenge in biology. The work would go on to win a Nobel Prize. The transformer had escaped the lab, but the public still hadn't noticed. That changed on November 30, 2022. OpenAI released ChatGPT, essentially GPT 3.5 with a chat interface and a crucial extra ingredient, reinforcement learning from human feedback, which taught the model to be helpful and conversational instead of just auto-completing text. It reached an estimated 100 million users in about 2 months. At the time, the fastest-growing consumer application in history. Overnight, AI stopped being a research term and became a household word. Students used it. Lawyers used it, sometimes badly. Every boardroom on Earth suddenly had the same agenda item. What followed was a land rush. 2023 brought GPT-4, which could pass professional exams and understand images. Anthropic launched Claude. Google merged its AI divisions and shipped Gemini. Meta released Llama with open weights, igniting a massive open-source ecosystem. Models learn to see, hear, and speak. Context windows, the amount of text a model can consider at once, exploded from a couple of pages to entire libraries, 1 million tokens or more. And AI stopped being a destination you visited and became a layer inside everything, your code editor, your documents, your spreadsheets. But bigger wasn't going to be the whole story. Around 2024, the frontier shifted from models that answer instantly to models that think first. Reasoning models, starting with OpenAI's O-series, and quickly followed across the industry, learned to generate long internal chains of thought before responding, spending more compute at answer time on harder problems. The results were startling. Meta-level performance on math Olympiad problems, elite competitive programming, PhD-level science questions. Then came the shock from the other direction. In early 2025, Chinese lab DeepSeek released a model matching frontier performance at a fraction of the training cost. Frontier AI, it turned out, could be radically cheaper. Prices collapsed. Architectures evolved, mixture of experts, designs now route each query to specialized subnetworks instead of waking up the entire model, like consulting the right specialist instead of asking one doctor to know everything. One researcher summed up the era perfectly. We stopped making models bigger and started making them wiser. And that brings us to now. The current chapter isn't about chat, it's about agents. AI systems that plan, use tools, browse the web, write and run code, and work autonomously for hours on tasks you delegate rather than conversations you supervise. So what does the frontier actually look like in mid-2026? 3 snapshots tell the story. OpenAI now ships GPT 5.5 as its flagship, iterating so fast that entire model generations, like GPT 5.2, get retired within months. Its successor, GPT 5.6, is already rumored, reportedly being tested internally while regulatory requirements slow its public release. New models don't just launch anymore, they get cleared. Anthropic, in June 2026, introduced something different. A whole new class of model above its previous top tier. Claude Fable 5 is the version anyone can use, shipping with extra safeguards around dual-use capabilities. Its sibling, Claude Mythos 5, the same underlying model without those restrictions, is available only to approved organizations. For the first time, the ceiling of public AI isn't defined purely by capability. It's defined by access policy. And then the counterpunch from the open world. That same month, Beijing-based Z.ai released GLM 5.2, roughly 744 billion parameters, a 1 million token context window, fully open weights under an MIT license. It beats GPT 5.5 on several long horizon coding benchmarks at about 1/6 of the cost. The gap between open and closed models, once measured in years, is now measured in weeks. Meanwhile, the bottlenecks have changed too. It's less about ideas now, and more about electricity. Data centers are on track to consume a meaningful share of global power. And regulation has arrived, with the EU's AI Act setting the first major rulebook for frontier models. But here's the remarkable part. Underneath the agents, the Mythos-class tiers, the open-weight giants, the trillion-dollar valuations, and the geopolitics, it's still, fundamentally, that same 2017 architecture. Attention, stacked deep, scaled up, and refined. 8 researchers. 15 pages. One idea that attention was all you need. They were more right than anyone could have imagined. The open question is whether the next 15-page paper is already sitting quietly on someone's hard drive right now. If this story was worth your attention, you know what to do. Thanks for watching Dots and Arrows.